Well, my name's Scott Cohen. I'm the Director of Special Projects for ABG Tag and Track, which is a wholly owned subsidiary of American Biomedical Group. We're a government contractor. We supply systems to everybody from NASA to the military, and then we also sell commercially into like governmental entities like airports, as well as non-governmental entities like hospitals. So we're at NASA today, and we did some measuring with the BLK 360 in order to figure out how we're going to move spaceship mock-ups around the building as they get delivered. NASA didn't really have any very good CAD plans or any good 3D drawings. So we used the BLK 360 and the Cyclone Register 360 software to generate point clouds, pretty much on the fly. As we were going around connecting the initial point clouds, we were putting them together inside the software so we could give a really good visual feedback to the NASA staff about what we're doing. We've been using the BLK 360 just over a year at this point. I think we were in the first or second batch of BLK 360s. In fact, we liked our BLK so much, and because of the support that we got from Leica with the initial one, that we went out and bought a second batch. It's super easy to use. It's super lightweight. It's about the size of a coffee can. I think it weighs maybe 2 pounds, and you can just take it anywhere. You can run it on a tripod. You can sit it down someplace. The stitching software, like with the cloud, as well as the visual matching, is really easy to use. I mean, we do it in the field, running on a Microsoft Surface with a Core i7, nothing real spectacular, like less than 3 gigs of processing speed. If we came into a space like this, you'd see that we're standing in a high bay with probably a 35-foot ceiling, and that there's all sorts of very interesting columns and structures around that would be almost impossible to measure with a device that's not a BLK 360 or a point cloud generation device. So the second part of what we're doing with NASA, beyond measuring where the spaceships are going, is we actually measure the inside of the spaceships. And we do that for the purpose of locating our Ultrac nano receiver units, which are small radio frequency devices that are used to keep track of other small radio frequency devices that go onto people, more specifically astronauts. And by precisely locating the astronauts, we're able to do time and motion studies and utilization studies of the spacecraft layout. And eventually these spacecrafts are going to go into what's called the cislunar orbit, where we'll send astronauts from Earth to this gateway to live for 30 days at a time. And then eventually the plan is to use it as a stepping point to both the moon and to Mars. Accuracy is really important. I figure the old way that we were doing it, anywhere from a year and a half ago with the total stations, or really going back even before the total stations when we were just using like disto type devices, probably non-line of sight, we are getting inaccuracies of anywhere from 2 to 3 feet over a distance of like 1,000 feet non-line of sight. And now with the BLK 360 and the CR 360 software, it tells me that over the course of 1,000, 1,500 feet, that we're getting accuracies in the 1/8" neighborhood. And that's running at a medium resolution. So if we went with a high resolution scan, we'd probably do a little bit better. So yeah, we're very happy, because the more accurate our data is going in, the more accurate our location data is coming out.